Okay guys, we have a request on certain questions from the homework. So I'm going to do that right now. Let's turn to the back side of this worksheet and let's do 14, 16, and 18. And we might as well throw in 24. Let's start with 14 and let's get rid of one fraction at a time. I'm going to begin with this first fraction. I want to get rid of this x minus 1 by multiplying that fraction by x minus 1. But I need to multiply everything by x minus 1. This times x minus 1, this times x minus 1. Okay, so yes, right here, the x minus 1 cancels with the x minus 1. The fraction is gone. I have 6 equals. Now, on the fraction that you see right here, it doesn't cancel. So you actually have to distribute. When it doesn't cancel, you multiply it. So I'm going to distribute 4 times x, that's 4x. 4 times negative 1, that's negative 4. And it's still over the x minus 2. Anyhow, let's move on to the next one. We're going to distribute 2 times x, that'll give us 2x. 2 times negative 1, that'll give us a negative 2. And it's still over that fraction x plus, or over that denominator x plus 1. And we do have a plus sign between those two fractions. Sorry, I went kind of crooked here. Anyway, we got rid of the first fraction. Now let's get rid of one of these fractions. I'm going to multiply everything by x minus 2. So I'm going to multiply this by x minus 2. I'm going to multiply this by x minus 2. And I'm going to multiply this by x minus 2. So the first one's pretty easy. 6 times x, that's 6x. 6 times negative 2 is negative 12. Let's now cancel over here on this fraction. Let's cancel the x minus 2 with the x minus 2. And we have the equal sign that comes down, and we still have the 4x minus 4. And now over here, the x minus 2 does not cancel with the x plus 1. So we actually have to distribute, but it's a binomial, right? It would be nice if I didn't have this 2x, if it were just a negative 2 that I could distribute. But unfortunately, it's not just a negative 2. It's actually a binomial 2x minus 2. Which means that we need to put that binomial 2x minus 2 in parentheses. There's going to be a lot of math to do here. What do I mean by that? 2x times x, that's 2x squared. 2x times negative 2, that's negative 4x. And we're going to distribute the minus 2. Minus 2 times x is a minus 2x. Minus 2 times negative 2 is positive 4. So keep in mind that this fraction is still a fraction. So let me actually start by putting a plus sign, by putting the denominator x plus 1, and then writing my answer, which is going to be 2x squared minus 6x plus 4 up here on the numerator. 2x squared minus 6x plus 4 on the numerator. Okay, now for my final step, my final fraction. Let's get rid of this fraction by multiplying everything by x plus 1. You know what? To make things a little easier for us, you see, it would be horrible to multiply this by x plus 1. I mean, that'd be nice. But then I have to multiply the negative 4 by x plus 1, the 4x by x plus 1, the 12 by x plus 1, and the 6x by x plus 1. And that would be ridiculous, a ridiculous amount of work. In math, there's many roads to the same place. Let's take the quicker route, the easier path. So what's the easier path here? You could actually move things around, combine like terms. So I am going to, since I do have a quadratic, I might as well move these guys over. That way we could have a quadratic equation that's set equal to 0. So I'm going to subtract 6x, and I will also add 12, which will cancel, and add 12. Okay, so on the left side of this equation, I have 0. On the right side, I have negative 2x. What is negative 4 plus 12? That is 8. So let me put a plus 8, positive 8. And we still have this fraction exactly the way it is right here. So I'm just going to copy and paste, make it a little quicker than me jotting it all down. And now I'm going to get rid of the denominator x plus 1 by multiplying everything by x plus 1. So I am going to multiply the 0 times x plus 1, which nothing happens. I'm going to multiply the negative 2x times x plus 1, and also the 8 times x plus 1. So when I multiply the negative 2x times x, that'll give me a negative 2x squared. When I multiply the negative 2x times 1, that'll give me a negative 2x. When I multiply the 8 times x, that'll give me a positive 8x. When I multiply the 8 times 1, that'll give me a positive 8. And you know what? I forgot to, the whole purpose of multiplying everything by x plus 1 was to get this last fraction to cancel right here. So I do end up with the plus 2x squared minus 6x plus 4, no more fractions. This is all equal to 0. So now at this point what we have to do is combine like terms. So let's begin with the highest exponent term, x squared. We have a negative 2x squared here. We have a positive 2x squared here. They cancel out, they disappear. Now let's combine the x's. We have a negative 2x with a positive 8x, that is 6x, and then 6x take away 6x completely disappears. So all these x's completely disappear. Again, a positive 6x and a negative 6x will cancel out. So what do we have left here, guys? We have the equation 0 equals 8 plus 4. So let me rewrite that. 0 equals 8 plus 4 is 12. What do you guys think of that? 0 equals 12. That is definitely no solution, because that's impossible. 0 cannot equal 12, can never equal 12. Your answer is no solution. That was a lot of work. It is what it is. Let's jump to 16. All right. So here you have two fractions, and they both have the same denominator, so that's even easier. All you have to do is multiply everything by that b minus 1. So that would imply that you multiply this b right here times b minus 1. So when you do that, distribute. B times b is b squared. B times negative 1 is negative b. And then we're going to multiply this guy also by b minus 1, which that's easy because it cancels. So what do we have left? The plus sign comes down. The 2b comes down. Let's write down our equal sign over here. Let's see what's on the right side of this equation. Again, multiply everything by b minus 1. That means this guy, the 1, also times b minus 1. So distribute 1 times b, that'll give you a 1b. 1 times negative 1, that'll give you a negative 1. And last but not least, we have this other fraction over here that we're going to multiply also by b minus 1. And when we do that, you don't actually multiply, it just cancels out. So what do we have left? We have this minus sign, but this is the tricky part. This is a binomial. So you have to put the parentheses around that binomial, because if you don't, it's this minus sign, it's going to look like it just belongs to the b, not to the minus 3, and the whole numerator is negative. So you need to distribute that minus sign. Anyways, there's our new equation without fractions. Let's distribute that minus sign, negative b plus 3. Let's rewrite everything else, the minus 1, the b, the equal sign, the 2b, the minus b, the plus between those two, and the b squared. So we have a quadratic equation, exponent is 2, and let's move everything to one side, and let's combine like terms as well to make it nicer. So on the left side of this equation, I could combine this minus b with this plus 2b, and what do I have left? A b squared plus 1b. Over here we could combine the b with the minus b, those eliminate. We could combine the minus 1 with the plus 3, and that'll give us a 2. Let's not forget that to bring down that minus sign. Now let's get this quadratic equation set equal to 0. So subtract 2, you will have your quadratic equation b squared plus b minus 2 equals 0. And any quadratic equation, you should try to factor it so you could split it, so you could solve it. So the question is, what times what is negative 2, that if you combine together is positive 1? Well, that would be a positive 2 times a negative 1. And when you split those, you're going to get two simple equations. B plus 2 equals 0, b minus 1 equals 0. That's because of the zero product property that you're able to do that. You get two answers, b equals negative 2 and b equals positive 1. Now you have your two answers, but don't assume that both of them work. Remember, we're dealing with equations that have fractions in them, which means that you do not want a 0 in the denominator. The negative 2 is okay because negative 2 minus 1 is not 0, but when you plug in this 1 minus 1 will give you 0 in the denominator, and anything that's divided by 0 is undefined. So we know that the b equals 1 doesn't work. That's what we call an extraneous solution. That just means extra answer. Now, you don't have to write this down. You just cross it out. Your only answer is b equals negative 2. Number 18, a great problem that shows why factoring is important to come up with your LCD if you want to get rid of all fractions at the same time, or even if you want to get rid of one of them at a time, it's still good to factor. As you can see, this is a quadratic trinomial. The a value is 1, which means you could probably factor, put a c right here and a c right there, and think what times what is negative 3, that if you combine together is negative 2. That'll be a negative 3 times positive 1. That'll give you a negative 3 if you multiply it, and it will give you a negative 2 if you combine it. So, ladies and gentlemen, this really does factor to this. And from there, it's just a question of getting rid of fractions, all right? So if you want to get rid of this fraction, you could multiply everything by c minus 3. As you could see, I put the c minus 3, c minus 3, c minus 3. I'm multiplying everything by c minus 3. And right here, they cancel out. So let's cancel. What do I have left? I have a nice, beautiful c plus 1. I have the equal sign that comes down. And over here, I distribute 4 times c, that's 4c. 4 times negative 3 is negative 12. Now, we do have a minus sign right here. Let's put that minus sign right there. And this is still going to be a fraction. So I'm going to put the fraction bar after that minus sign. And of course, the c minus 3 up here cancels with this c minus 3 down there. So my new fraction is still a minus 12 over c plus 1. Now again, I need to get rid of this fraction by multiplying everything by c plus 1, but before doing that, we might as well move things around to make them to make the equation smaller, simplify it, right? In other words, I could take the c, subtract it, and it'll give me 3c right here, 3c. And I could also take the 1 and subtract 1 and subtract 1, and negative 12 minus 1, that is a negative 13. I probably should have moved everything to the left side of the equal sign, but that's okay. We'll get to the right answer anyway. Right here, there's nothing left on the left side, and we did get the 4 take away 1, which is 3c, and the negative 12 and negative 1 is negative 13. Now we still have this minus fraction, so let's write that down. Minus 12 over c plus 1. Now let's get rid of that fraction by multiplying everything by c plus 1. So when I say everything by c plus 1, this by c plus 1, this by c plus 1, the 3c times c plus 1, and even the 0 times c plus 1, but we know that that doesn't change anything. 0 is still 0 when you multiply anything with it. Anyway, so let's distribute. We have the 3c times c, that'll give us a 3c squared, and then we also have the 3c times 1, let me actually draw an arrow, that'll give us a positive 3c, and then we have the negative 13 times c, that'll be a negative 13c, and we also have the negative 13 times 1, should have been a parenthesis there, that'll give me a negative 13, and last but not least, the c plus 1 up here cancels with the c plus 1 down there, so I am left with just a minus 12. So I put minus 12 right there. Now this is all equal to 0. I guess it did work out pretty well because I end up with the quadratic, and quadratic equations, you're supposed to set them equal to 0. Let's simplify this by combining like terms, all right? So I'm going to combine the c, the positive 3c, with the negative 3c, giving me 10c, negative 10c left over. So I really have the 3c squared minus 10c, and then I might as well combine the negative 13 with the negative 12, giving me a negative 25, minus 25. All right, so we have a quadratic trinomial set equal to 0, but instead of putting the equal to 0 on this side, I'm going to put it on the other side. And now we could factor, or attempt to factor, split, and solve, or at the very least we could use a quadratic formula. How do we factor when the a value is not 1? Well, you got to go through that long process. Step 1 is to multiply a times c, and that's 3 times negative 25, that's negative 75. And then you got to think of the multiples of negative 75 that combine together to give you the middle value, negative 10. So let's just go through. Negative 1 times 75, negative 2 doesn't work. Negative 3 times 25, that works. Negative 4, I don't believe that works. Negative 5 times 15, I believe, yeah, that works. And that's the combo that we want, right? Because if we combine negative 15 and negative 5 and 15, that'll give us a positive 10, and we know that we want the middle value to be a negative 10. So I have the right numbers, I just have the wrong signs. So let's put this as a positive 5 and a negative 15. This is the correct pair of numbers that I want for step 2. Now we're moving on to step 3, which is to write it in factored form, still equal to 0. And we put a x, but it's not x, it's a c. So put a 3c here and a 3c there. And what do we put in these blank spots right here? What do we put in here? We put the pair of numbers from step 2, the positive 5 and the negative 15 right in there. And then the fourth magical step is to divide the binomial by whatever you can. The first one you can't divide by anything, so it's still 3c plus 5. The second one you could divide both by 3, and that'll give you a regular c minus 5. It's still equal to 0. This is factored form. Now we could split it and solve. So when I split, I get those two equations, and when I solve it, I'll get 3c equals negative 5, which means final answer c equals negative 5 thirds. C equals negative 5 thirds. The other one's easy, plus 5, and you'll get c equals 5. So those are your two answers, but take a moment, go back to the original, and see if any of those answers will give you a 0 in the denominator, okay? So obviously, you'd need a positive 3 to give you 0 here, so we're clear. No answers are positive 3. Now the question is, if I plug in a 5 right here, plug it in a fraction, you're going to end up with fractions, so you don't have to worry about it because it's not going to give you 0. Plug a 5 right here, 25 minus 10 minus 3, that's not going to be 0, so you're good. Both of those answers are correct. Let's move on. Let's go to this last one here. As you could see, none of these could be factored. They're not factorable. So we just need to start getting rid of fractions. If you want to get rid of this one first, let's multiply everything by the binomial a plus 5. And I say everything by a plus 5. I'm talking about the 3, this fraction by a plus 5, and this fraction by a plus 5. So there it is. I have all my terms being multiplied by the binomial a plus 5. Oh, I forgot the parenthesis again right there. Now, let's distribute 3 times a, that's 3a. 3 times 5, that is 15. The equal sign comes down. Now notice right here, nothing cancels. It's a binomial and a binomial. You can't cancel those. So I am going to have to multiply this binomial with the numerator, which is also a binomial. So that in itself is going to be a little entertaining. What do I mean by that? Let's zoom in. We have a binomial times a binomial. So we're going to have to distribute 6a times a, that's 6a squared. 6a times 5, that's 30a. Negative 1 times a, that's negative 1a, and negative 1 times 5, that's negative 5. When I combine the 30a with the minus 1a, that'll give me a 29a, that's positive. So I really have 6a squared plus 29a minus 5, and it's still going to be over the denominator of 2a plus 7. So all of this over 2a plus 7. Let's write that down right here. Again, we have our fraction. We have 6a squared plus 29a minus 5, and it's going to be over the 2a plus 7. Moving on to the third part of our equation here. This a plus 5 and that a plus 5 completely cancel out. That's nice. So we just end up with a plus 22 right here. So let's do that. That's fine. Plus 22. So here's my new equation. It only has one fraction now. We could simplify it a little bit more. What do I mean by that? We could actually take this 22 and move it over here so that there's less numbers, right? I'm going to have to multiply everything by 2a plus 7. So instead of having 1, 2, 3, 4 things to multiply by the denominator 2a plus 7, I want to move the 22 over. That way I'll only have 3 things to multiply. How do I move the 22 over? By subtracting it. And when you go 15 take away 22, you get a negative 7. You still have the 3a right in front of it, and you still have the fraction 6a squared plus 29a minus 5, all divided by 2a plus 7. So here's my new equation. Let's get rid of the fraction by multiplying everything by 2a plus 7. That'll cancel out, but you're going to have to multiply the 7 by 2a plus 7, and also the 3a, you're going to have to multiply it by 2a plus 7. Again, multiply everything by the denominator of the fraction that you want to get rid of. So we will have to distribute 3a times 2a, that is 6a squared, 3a times 7, that's plus 21a, then the negative 7 times 2a, that's negative 14a, negative 7 times positive 7 is negative 49. Let's not forget about the equal sign. Let's put it right here. And because the binomial is canceled, this just comes down. So I have the 6a squared, the plus 29a, and the minus 5. Here's our long, ginormous quadratic equation. So let's set it equal to 0. Let's start moving things around. I'm going to start with the 6a squared. I want to get rid of it by subtracting 6a squared. It cancels out. It disappears. What I do to one side, I need to do to the other side. So I have a 6a squared that I'm subtracting over here, and it also cancels out. That's great. That way I don't have any more a squares. I just have a's. What else could we do before moving things around? We could combine like terms on the left side. We have a 21a minus 14a. 21 minus 14, you're talking about 7 a's left over. So we have 7a, and let's bring down the minus 49. Let's bring down the equal sign. Let's bring down the 29, the minus 5. Again, I just 21, take away 14, 7a. Bring down the minus 49, bring down the equal sign, bring down the 29a. Oops, I forgot the a. That's good. I went back and explained my steps. And the minus 5. So this is our new red equation right here. Now let's solve it. We want a's on one side, numbers on the other. So I'm going to subtract 7a. 7a, that way it cancels out. Subtract 7a. And when you think about 29 take away 7, you will get a 22a, and then bring down the, let me do this in black actually, 22a, bring down the minus 5, bring down the equal sign, bring down the minus 49. And now we're going to get rid of that minus 5 by adding 5, and we will end up with a negative 44 equals 22a. Which means 22 times a, which would mean that on your last step, to get rid of that multiplication of 22, you divide by 22. And what you do to one side, you do to the other side, giving you the final answer of a equaling negative 2. A equaling negative 2. A equals negative 2. Now, I hope that all this work paid off, but we do need to double check and make sure that our denominator doesn't end up as 0 when I plug in negative 2. 2 times negative 2 is negative 4, plus 7 is not 0. Negative 2 plus 5 is not 0. I'm good. My answer, number 24, is a equals negative 2.